Another specific type of continuous distribution is a continuous exponential random variable. So we're going to define this one as x is an exponential distribution with variable lambda. And if I do it this way, so basically I'm just setting up an exponential function where I have my variable is lambda. In this case, my x is going to be positive, and my lambda value is also going to be positive. And here, x could be greater than or equal to 0. Doesn't matter so much. Let me make it more clear that that's a lambda. So if I want to think about my continuous probability, then my f of x is going to be the integral from 0 to x. And again, I'm going from 0 because my x is positive, so it's 0 elsewhere. And then I'll just integrate my function, lambda e to the negative lambda. I'll use t. So this integral is I'll divide by negative lambda, so I'm going to end up canceling this out. I'll have negative e to the negative lambda t evaluated from 0 to x. When I plug in the 0, I'm going to get negative e to the 0, which is negative 1. When I plug in the x, I'll get, well, let's just do it. So we'll have negative e to the negative lambda x minus negative, so that'll be plus e to the 0, which of course is 1. So we get 1 minus e to the negative lambda x. If I want to find my expected value, then I'm going to take the integral. So this is for x greater than 0. So I'm going to integrate from 0 to infinity of x lambda e to the negative x, e to the negative lambda x dx. This is integration by parts. So I would set up my u to be x, my dv, I will make lambda e to the negative lambda x. So I like having that lambda in here because then when I integrate, it's going to cancel out. I'll get negative e to the negative lambda x. My du, of course, is just u. Because it's an improper integral, I'm going to say this is the limit as b goes to infinity of uv evaluated from 0 to b minus integral v du, so minus minus makes plus, integral from 0 to b of e to the negative lambda x. Go ahead and simplify all this, and you should find that your expected value is 1 over lambda. I'll leave it up to you to prove that the variance for x is 1 over lambda squared for this exponential random variable distribution.